Hello everyone, welcome back. So today we are going to go over a really fantastic kernel, which is serving as the baseline for most of the work that is being done around this competition. So here this paper is authored by a username person with a username called as Ifos. So he's currently at the first position of this competition. So which means he has used some form of other of this same idea he has shared, and yeah, it has produced a pretty good uh, improvement over what we have done in our previous method. So I will just go into his code and explain what is happening and how are we about to use it in our model. And yeah, so I made use of this kernel and I got into got a score of 0.6, which is really good compared to our last 0.1 score which we got. So yeah, so in the next video I will talk about that, but now I'll just go ahead and explain his work here. So yeah, so the main idea behind his approach is, instead of passing in the entire image of this tissue sample, he is going to chop up and then take only the interesting parts out of it and then pass it to the model. Okay, and he thinks if he do it in that way, it's going to be more effective. And yes, it is. Since most of this images is occupied with white, or I would say background image, white or black, it doesn't matter. The main interesting feature is not very visible to the model that we trained, right? So if we chop it up and then take only the interesting areas, so areas where there is lesser white, or the ratio between the white and the content uh, is higher, uh, is lower, so white and the content is lower, then we could use it for learning more. So that's what he's doing. He's chopping it and then selecting good styles of with content. So let's go over it. So initially it's the same imports and he is doing. So he is planning to zip it up into files so that he could use it as a data set, as I showed in my last video. So here the patch size is taking it as 128, so that is a tile size, sorry, and then a maximum of, he wants to take 16 tiles of every sample, tissue sample we get. So he wants to take 16 of it. So it's a simple code only. So I will go into the main part, so tile part. So the tile function takes in two important things. One is the image and then mask. If you want to do the same operation on mask and you want to store it and you want to use it further, you can follow it. But if you don't want, you can remove the mask also. But it's up to you. You can decide on which one is good for you. So we are going to take the image and then we are going to get the sizing, and then since we are going to chop it up into equal size of gridding, so the size of the grid will be 128 cross 128. Not every image by default is going to be divisible by 128, so we are going to find the size of it and then find the exact padding value, so that we pad the image with zeros, and then we chop it into 128 plus 128 grid. So that's what happening here. He's going to find the padding of it, and then he's going to calculate the pad, and then he's going to pad them both in the left and the right side of the image. So that's what happening till here. Okay, and then comes the interesting part. How are you going to make them into grids, and what is the fastest way to make them into grids? Okay, you can't just manually write a indefinite loop you will go from the 0 to 128 and then 128 to 128 plus 128. So that will be a tedious work, right? So instead of that, he cleverly used resize option of numpy to his advantage. Okay, so reshape option of numpy to his advantage. So what is he doing is he's just going to convert them into eventually he wants to convert them into n number of patches of size 128 cross 128 cross 3 just by using a reshape and transpose methods. That's what he's applied in this two lines. So reshape image shape divided by SEZ. So SEZ is 128 and then SEZ, and then image shape 1 divided by SEZ. So double forward slash means you'll be getting an integer instead of getting an absolute float value. So after dividing, so that's the thing. And then 3 channels. So he's just reshaping it. He's just doing the same thing for both the mask and transpose. So we were previously talking about this 16 patches, right? So what if the particular image you are working, you're not able to get 16 patches? The total number of patches lesser than 16. It is highly unlikely, but what if in that case? So we are just going to create a empty image just to fill in those spaces. So that's what happening here. Empty image of mask means constant 0 value, and then image means 255 value. So it will be just a blank white image with a mask of black black values, nothing much. Okay, and then here we have to discuss about how we are going to select the topmost slides which has more pixel more content density compared to white space. So here we are going to use argsoft. So argsoft is a package from is a function from numpy which is going to arrange them, give you an ascending order arrangement. So it will go from lower value to higher value. So what he has used it intelligently is he has reshaped the images into a single dimension image of batch size total number of images. Say after all this work we got around 100 patches of 128 cross 128 cross 3. Then he is just going to reshape them into 100 comma whatever the number is, 128 cross 128 cross 3, whatever the number comes, so that it will be a single long vector that is stacked with each row corresponding to each sample, 100 samples, and then he's going to sum them so that we will be left out with number of samples and then the total number of sum. So it's just like adding all the pixel values together, and then we are going to pass it to argsoft, which is going to arrange them in ascending order, right, smaller to higher. So when we are talking about having more white patches, then correspondingly if a patch has more white spots, its total sum is going to go higher because the white is of value 255 cross 255 cross 255. So the value is really high compared to other color values. So if your patch is full with other colors, then you are going to be at the beginning, the lower level sum. Whereas if your patch is like 3/4 occupied with white, then this total sum will be really higher. So you'll be ranked up somewhere in the last. So we are going to arrange them in ascending order, and then we are going to take the first n number of samples. Okay, and this argsoft will not return you the arranged array, like not rearranged array. It just return to you the index of the original array which is being passed to it, and which are the locations where this elements happen. Say the first element after sorting happens at fifth position of the input array, then the index first value will be 5. So that will be corresponding to the fifth position of this uh, fifth position of this input array. So we're going to take those index and then we're going to pass it to filter the image array and the mask array which you have generated so far with this. So by passing here, we'll just have only those selected images and masks, and then the first one will be corresponding to the higher content density compared to the last one. So we are doing it both the way. So you can do apply a lot of analysis on top of it. So the slides are also arranged for you in that manner. So that's a good thing. And then we are just going to make a dictionary out of it, and then we are going to ship those dictionary. And that ends with that is the main part. And then yeah, that's the main part of this code, and he has written it so well, like it just fits into like within 15 lines or so. And this is just for cosmetics, nothing much. So we are going to read the image mask, and then we are going to get the tiles, and then we are going to store them. We are just going to uh, you know uh, normally we will save, right? So instead of just stopping with saving, he's just going to write them into zip file and then ship it. So he's just doing the same thing here. Overall, this is a pretty good kernel, and if you really want to work with this project, you have to take a look at this. Some way or other, you are going to come back to this idea of dividing the image into subtiles and then using it. So this is a really good kernel, and yeah, so you should take a look at it. So in the next upcoming video, I will discuss about my solution where I got a zero point 0.6 score, and which is an improvement over our 0.1 score. Uh, yeah, so that's the content for the next video. So yeah, hope you enjoyed this one, and see you later.